This lesson is on polynomial functions. First, we're going to talk about the degree. So if we have the function written as number 1, f of x equals x to the 5th plus 5x to the 3rd plus 4x, here the degree is the largest exponent. So this is degree 5. The sign is in front of the x to the 5th, that's a positive. 5 is an odd number. So if you look above, when the ax to the n is odd, notice the arrows point in opposite directions. So the opposite of a positive is negative. The opposite of a negative is positive. That's your end behavior. What does the graph look like at the very end of the graph? Okay, here in number 2, we're in factored form. So the degree is the sum of the exponents of the variable. If you remember, for a constant or number, the degree is 0. So you're going to find each variable term, and we are going to sum the exponents. So in this case, we've got the understood 1. 1 plus 3 is 4. That's degree 4. The sign in front is negative from the negative 2. And 4 is even, so they'll be in the same direction, being down, down. Okay, now we want to find zeros. And the zeros are the x values of the x-intercept. That's when y equals 0. Okay, so the problem you're going to solve is 0 equals x cubed minus 5x squared minus 16x plus 80. And what we want to do is to solve this by factoring with grouping. So I'm going to group 2 and 2, and we use GCF. The GCF of x cubed minus 5x squared is x squared, and then you're dividing by x squared. X cubed divided by x squared is x, minus 5x squared divided by x squared is 5. Here you can take out a negative 16, you get x minus 5. So 0 equals x squared minus 16, the first two terms in front, times x minus 5. Okay, so that becomes 0 equals, now if you remember, x squared minus 16 is called a perfect square, so that's going to be x minus 4, x plus 4, x minus 5. And setting your pieces to 0, you're going to get x equals 4, x equal negative 4, and x equal 5. Okay, so number 4, determine the zeros of the function defined by x to the 6th plus 4x to the 5th plus 4x to the 4th. So again, 0 is equal to x to the 6th plus 4x to the 5th plus 4x to the 4th. So anytime you have a polynomial, you always want to look for a GCF, greatest common factor. So if you notice here, the coefficient of x to the 6th is 1. So our GCF is going to be x to the 4th. It's the variable with the smallest exponent. So if I factor out an x to the 4th, okay, 6 minus 4 gives you x squared. 5 minus 4 gives you 4x. And x to the 4th divide out, plus 4. And then we have 0 is equal to x to the 4th. And so what we want to know is what times what is 4 that adds to 4. So 2 times 2 is 4. 2 plus 2 is 4. So you have x and x. And to get your plus, you're going to do a plus 2 and a plus 2. So your answer is this. X to the 4th equals 0. And x plus 2 equals 0. Those are the same, so we can just solve one of them. X equal negative 2. And here you're going to take the 4th root of both sides. And you're asking yourself, what times what is 0? And we get x equals 0. Okay, so our answers here for number 4 are x equals 0, comma negative 2. And the answers for number 3 are 4, -4, and 5. Okay, so let's go to the next page. Number 2. We're still going to continue with this idea of the degree and the sign and the end behavior. All right, now we want to determine the zeros and the multiplicities. Okay, so the multiplicity has to do with the exponent. So let's make a note. Multiplicity is the exponent of the zero. Okay. So what we're going to do is we are going to go back, and there are 3 zeros. We have 8x equals 0. We'll solve that one. X minus 1 equals 0. And x plus 3 equals 0. Okay, so divide by 8. You get x equals 0. Now, the exponent is a 1, so the multiplicity is 1. Okay. Then we have x equals 1. If you look at the exponent, that exponent is a 2. So your other zero is x equals 1. Let's put a semicolon. And that is multiplicity. Now I'm going to abbreviate it, MULT, multiplicity 2. Then you're going to subtract 3 here for both sides. You get x equals 3. So your third zero is x equals 3. And the multiplicity is 3. Okay, now the multiplicity and the zeros do not have to be the same like they are. And that should actually be -3. X equals -3. Let's go back at that. Because that was a -3 there. I subtracted 3. Okay, so that's -3 multiplicity 3. So let's write that a little cleaner. Okay. Now, if the multiplicity is odd, now notice nothing about the zero. If the multiplicity is odd, it's going to cross, and even it'll touch. So let's look at this one. If you notice, there's 1, 2, 3 x terms. So there's going to be 3 zeros. So if you look at x squared, because it's by itself, so for x squared, the 0 is 0. Okay, if we said x squared equal to 0, and we square root both sides, we get x equals 0. So if there's no number added or subtracted, 0 is your 0. Okay, x plus 4 equals 0, we get -4. X minus 7 equals 0, and you're going to get 7. Okay, the multiplicity is the exponent. All right, so reading carefully, the exponent on x squared is 2. The exponent on the -4 is a 1. And the exponent on 7 is 3. Okay, so 2 is even. So it touches. Okay, so again, we're referring right to the multiplicity. The multiplicity determines touch or cross. 1 is odd. So it's a cross. And 3 is odd. So it's also a cross. Now, before we can graph this, we're just getting our different pieces of information here. We need to be able to find these pieces of information, then we can do a sketch without a graphing calculator. Okay, so the maximum number of turns is degree minus 1. So max number of turns, I need you to memorize this for me, is equal to the degree minus 1. So in this case, this is equal to, now notice it's already added and subtracted, so the polynomial is written out. So the largest exponent there is 3. So we're going to do 3 minus 1, which is 2. So the most times it can turn, so that means the maximum number of minimums and maximums is 2. Okay, so this says determine the degree. So we're going to go the other direction. So if you're given a picture, the degree is equal to the max number of turns plus 1. So for example, if you notice my endpoints here are in opposite directions, I know that has to have an odd number degree. Okay, so 3, 5, 7. So the minimum degree for this one is the 2 turns, 1, 2, plus 1. So that's equal to 3. So this would be degree 3, which confirms it because the arrows are pointing in the opposite direction. Okay. All right, so let's look at this one. Okay, I forgot to mention something. I have to have a polynomial. So a polynomial has to be smooth and continuous. Does everybody see the corner here? We have to really watch out for the corners. This here, if there's a corner like in the absolute value graph, it is not a polynomial. You can't tell me a degree or anything. I know it does turn around. We would consider that a maximum, but this is not a polynomial because we have a corner. Okay, the other ways it cannot be a polynomial is if you have a jump. Example, like this. If my picture goes like this and then I go like that, piecewise we studied earlier, this is not a polynomial. It's not continuous. Okay, so if it's not a polynomial, we cannot even begin to talk about the degree. All right, so let's do this one here. Notice what I'm going to ask you guys. Degree, sign, end behavior, zeros, multiplicity, touch or cross. The zeros are actually the x values, the x-intercepts, and then what the y-intercept is, and we'll sketch it. So your degree is 2 plus 1 plus 1. So my degree is 4 because I add my exponents. 2 plus 1 plus 1. My sign is positive. So that means this picture is going to go up, up. Okay, so on your lab, we're going to do zeros, multiplicity, and then touch or cross. We're going to make a table. Just makes your life a little bit easier. Okay, so if I count, there are 1, 2, 3 zeros. Okay, so how do I find my zeros? So x minus 1 equals 0. So I'm going to add 1. So x equals 1. We have x plus 3 equals 0. So I'm going to subtract 3 from both sides. X equals negative 3. And you have x minus 4. Please notice if you have the x terms, x plus or minus, that your answers are opposite. So that would give us x is 4. So you could just look at it and say, the opposite of subtracting 1 is 1. Opposite of a plus 3 is a minus 3. Opposite of a minus 4 is 4. Okay, so your multiplicity is 2, 1, 1. So now be really careful here. Okay, so the multiplicity gives me my touch or cross. So 2 is even, so we have a touch. 1 is odd. Notice I'm totally ignoring the zeros right now. We're going to cross. 1 is odd, so we're going to cross. And we'll explain what that means. Okay, the y-intercept is where x equals 0. So we're literally going to plug in 0. 0 minus 1 squared times 0 plus 3 times 0 minus 4. And I would pick up a graphing calculator to double check myself. So that's negative 12 times 1. So it's the point 0, negative 12. Okay, now how do we proceed? So first of all, we're going to plot our zeros. Let's say the 0 value so you don't get confused with 0. So I'm going to see, I see 1, negative 3, 4. So I'm going to graph 1, negative 3. I'm counting. 4. Okay, first thing we want to do is put those on there. Okay, number 2, let's put on the end behavior. Okay, so I'm going to look at, so it's up, up. Now give me a little bit of attitude. We have a little curve there. So I know that it's going to look like that. I don't know what's going on in the middle, but I know that. Okay, in the middle here, then number 3, we're going to do our cross and touch. Now these zeros are going to pretend they're like a magnet. So when I cross or touch, it's going to go back to the 0. So again, this is a rough sketch. So if I start with negative 3 here, negative 3 is a cross. That means you go from the positive to the negative. Oh, and since we know our y-intercept is negative 12, this is 10, 20, 30, 40. So I'm going to go to about right here. And it comes back like that. Now, look at 1. 1 is even. So that's a touch. A touch is where you stay on the same side. That's a touch. And then we cross it. So you can see, let me do that again. Okay, so let me put my 1 back here. All right, so you can see that when I'm going to give it, you know, it's going to change direction. That's called an inflection point. When you're going up and then you start going down, you'll learn more about that in calculus. So it's going to go here. Now, the problem is I don't know what that point is. I'm going to call this a sketch here, okay, because I don't know really how low I should go. Actually, my y-intercept is off, so let me correct that here. And again, it's going to just be more of a sketch. Okay, so I'm going to come down to right here. And then that's my touch. And that's a cross. So if you notice going blue to purple, positive y to negative y on the left side, that's a cross. And then we touch it. We stay below. Your graph is below the y-axis. And then you cross above. Okay, so that is 3.2 polynomial functions. So if you need to, watch the video again or listen to the video again and watch me work it. And go do math and have a great day.